I guess a lot of people are still at lunch, but we'll get started. Today we will be talking about jurisdiction-aware databases with Vitess. When we proposed this talk for the conference, the way we titled it was Geo-Partitioning. And the answer to geo-partitioning your data, we are claiming, is Vitess. And in this talk, we will talk about how you can use Vitess to geo-partition and also show a demo of it working. My name is Deepthi Sigireddi. I'm a software engineer at Planetscale, and I'm a maintainer of Vitess, which is an open source CNCF project. Vitess graduated from CNCF in November, and it's only the 8th project to have graduated from the CNCF.
My name is Jitendra, short Jiten Vaidya. The best way to pronounce my name is the letter G, number 10. I used to manage the SRE and DBA teams at YouTube back in 2010 when the Vitess project was started there by my co-founder Sugu Sugumaran and another early engineer at YouTube for scaling YouTube's databases. And for the last 2 years, I have been the co-founder and CEO of Planetscale, which is a company that we founded for giving commercial support for Vitess and making Vitess successful commercially. What I'm going to do is first start talking about the problem that we are solving. But before I do that, thank you everybody for coming here this afternoon, and thank you Sydney. It's a lovely city. This is the first time that I have been here, and it totally lives up to its billing so far. So thank you. So what problem are we trying to solve, right? You all are probably familiar with the GDPR regulation that the EU passed a few years ago. And there are many different aspects to GDPR, but one of the aspects is data locality. And what it roughly translates to is that if you have a particular user belonging to a particular political entity, the data associated with that user needs to live in physical infrastructure, which is bounded by the boundaries of that jurisdiction, right? And basically, that's the problem that we are trying to solve. And many times to support this kind of requirement, you need to re-architect your applications, which means that all layers of your application need to be aware about the geographical location of a particular data and then take appropriate actions for saving that data in appropriate places. And this is a daunting task. I mean, you don't want to re-architect your existing applications, or suffusing this logic throughout your application makes the velocity with which you can deliver new features go down, right? Also, if you have an existing monolithic database that you want to make compliant, migrating the data from this existing database into multiple database clusters which are resident in multiple jurisdictions is a pretty daunting operational challenge, and especially without taking any downtime, right? So these are the problems that we plan to show you a solution for today using Vitess. So let's start out by talking a little bit about Vitess. How many of you are familiar with what Vitess is? Okay, so roughly about 25%, 30% folks. So let me tell you what Vitess basically does. How many of you are familiar with what the term shard? Okay, almost everybody knows what a shard is, right? So Vitess is a sharding middleware that sits between your applications and multiple shards of MySQL databases. It gives your application the view that it's talking to a single monolithic database, and your application doesn't have to be aware that it's talking to a sharded database. The way it does it is because of two things. One is that it has a full MySQL parser built into it, and second is it supports the MySQL binary protocol. So it presents itself as a MySQL database to your application. So let's take a quick walk through this architecture diagram, right? So everything on the left-hand side of the horizontal dashed line is your application. There are app servers, maybe there are batch jobs, etc., accessing your database. Everything to the right-hand side is Vitess and MySQL clusters. VT-Gate is the first component that your application connects with. VT-Gate is a stateless proxy, has a full SQL parser built into it, and also supports the SQL binary protocol. So it presents itself as a MySQL server to your application. VT-Gate gets the query, parses it, looks at the where clause, and figures out which of the shards the query should go to, right? A Vitess cluster can support multiple key spaces. A key space is basically equivalent to a database. What is shown here is an n-sharded key space. Each shard, at its heart, is basically a MySQL cluster that you know and love with one master and multiple replicas. Vitess makes the distinction between replicas and what we call analytics replicas. Analytics replicas, we don't care about the replication lag. Members of the analytics replicas are not candidates for becoming a master for high availability. So one master, multiple replicas with standard MySQL binary replication turned on. That's what a shard is, but with one difference. Every MySQLD in that shard has a VT tablet process that sits next to it, typically on the same host or the same pod that your MySQLD is running on, talking to it through a Unix domain socket, right? It doesn't have to be on the same host. It can talk TCP/IP sockets also, but you typically run both of them adjacent to each other. So VT-Gate it gets a query, sends it to, parses it, figures out which shard, sends it to the VT tablet. VT tablet parses the query again and does a whole bunch of things to protect the underlying MySQLD. For example, it adds limit clauses on your MySQL query if it thinks that this query is going to return more than 10,000 rows. 10,000 is, of course, configurable. But basically, it's pretty easy for somebody to take down your database by writing a query of death. That pretty much becomes impossible under Vitess because of all these protections. It also gives a timeout for every transaction, timeout for every query. It does connection pooling between the VT tablet and MySQLD. It also does some other cool things like hot row protection for reads and for writes. So as I said, your MySQLD runs a lot better under the care of VT tablet than it would otherwise. The topology server can either be an etcd cluster, a zookeeper cluster, or a console cluster. That's where all the cluster topology is saved. So how many key spaces are there? How many shards in each key space? How many replicas in each shard? And what are the IP addresses and port numbers for each of those components. So cluster topology is saved there. And the second and more interesting information that is saved there is how a particular key space is sharded. So that's the two type of information that's saved in topology server. VTCTLD is the control plane for Vitess. So this is sort of the high-level architecture of Vitess, what this does. Just to give you the context, one thing that is not shown here are cells. We will talk a lot more detail about cells. At YouTube, the biggest key space that we had 256 shards. Each shard had one master, of course, and between 80 to 100 replicas distributed across 20 data centers. So between 25,000 and 30 nodes as a part of a single key space, application with giving the application the view that it's talking to one humongous database. So all of YouTube's user and video metadata lived in there. So I'm going to now drill down and talk about various other concepts that we need specifically for putting together a cluster that helps us solve the GDPR data locality problem, right? So the first concept that Vitess supports for this is cell. So a cell is basically a failure domain isolated from failures in other cells. It's a group of servers and network infrastructure. Example, it could be a full data center. It could be a rack in a data center. It could be an availability zone in a region. It could be a Kubernetes cluster. Any of these things, basically a collection of groups, servers and network infrastructure, which can be treated as a failure domain. And as you can see, these are physical things that can have physical boundaries, which means that they can be located in jurisdictions where you want them to be. So that's what we are going to use the cell for. Now let's talk about what a key space is. So key space is a logical database in Vitess. If you have a single sharded key space, that's identical to a MySQL database, no different. But if there are multiple shards in a key space, multiple MySQL clusters, multiple masters, each with identical schema, right? That's what a key space is. And in either case, a key space, whether it's single sharded or multiple sharded, it appears as a single monolithic database to the application. The application can't treat it that way. Now, what's a key space ID? Those of you who are familiar with key value databases probably have some way of thinking about a key space ID. Basically, a key space ID, you can think of it as a street address of a row. It decides where a particular row lives. And the way in which Vitess key space ID is different from the key used by key value stores is that it's a completely internal Vitess concept. It's not stored, it's calculated, right? The application doesn't need to know about the key space ID at all. And it's, the key space ID for a given row is used to decide which shard a particular row should live on. So let's jump in and see how this is actualized. This is actualized using something that we call v-index. So we have extended the relational semantics. Your relational databases have schemas. A sharded database that runs under Vitess has a v-schema. A v-schema basically is a collection of v-index definitions. What is a v-index? A v-index tells Vitess how a particular table in your key space is sharded, okay? And it needs two pieces of information to, it needs to define two pieces of information. First, what column in that table should be used for sharding the data in that table? And second, depending on the data type typically of that column, what sharding function should we use to calculate the key space ID, which will allow us to decide where that row goes. So two pieces of information, column and a sharding function, right? So here is a quick example that let's say that there is a table called customer. It has a column named ID. This is a numeric column, and we want to use a sharding function hash. And so for a row where the ID value is 123, the key space ID would be equal to hash of 123. Pretty straightforward. Now let's talk a little bit about what a shard is conceptually. So a shard is basically just, it has a begin and an end value for the key space range that that particular shard serves. So for a single sharded system, the begin value would be 0, 0, the end value would be FF basically. What that means is that any key space ID is always going to live in that shard, right? So there is a begin value, there is an end value, and for a given row, when you calculate key space ID, if begin is less than or equal to key space ID less than end, if that condition is true, then that particular row belongs in that shard. Each shard physically has one master, has multiple replicas, and those replicas can live across multiple cells if you want, or they can be in a single cell. Sharding functions, which we talked about a little bit when I talked about Vindex, we give you 6 predefined sharding functions, which are described here. But one of the coolest things about Vitess is that you can write about 40 to 50 lines of Go code and write a sharding function of your own, which satisfies the interface for sharding functions, and then you have complete control over how your data is distributed, right? And in today's demo, to satisfy the GDPR locality, what we have done is we have written a custom v-index that allows us to do this. Typically, you end up using either hash, which is a 3-dash null key hash of numeric columns, or you end up using the Unicode loose MD5 on basically varchar or var binary columns, right? That's what you typically end up using. But people have used, I mean, you can even just have a JSON map that maps a value, the column value to a key space ID for satisfying. Typically, when people migrate, if they have their own way of sharding, that can be expressed through a JSON table and so on. Yes, many different ways of doing this. So that's the numeric static map. So here we are going to use a custom sharding function. So in general, the solution is going to look like this. What we are going to do is that we are going to specify the column in our table that we will use for specifying, which is a marker of a location. In this case, we will use a country column. But the v-index or the solution that we have come up with sort of thinks of the problem in at two different levels. One is jurisdictions like NAFTA or EU or a country could be jurisdictions. And the second is some marker of location for a particular user or a particular piece of data, right? And a mapping between the jurisdiction and various, the lower level values. So the lower level value that we will use here is a country, but it could be a zip code, it could be an area code, it could be a country code for phone numbers. It could be any of those things, right? And what the way we are going to physically make sure that a piece of data lives in a particular bounded location is that we are going to start cells in different jurisdictions, and then we are going to make sure that a shard lives in a particular cell, and then our v-index and sharding function will make sure that data for a user which belongs to a particular country gets saved in that shard, and thus in that particular jurisdiction. So that's the shape of the solution. And with that, I'm going to hand it over to Deepthi.
All right, so the way we have set this demo up is that we have built a cluster already in GKE where we will store the data that we want to store, and we have written a custom index which will route the data appropriately to the region. And this cluster has multiple cells and multiple regions and countries. Here is some sample data that we will insert into our sharded database, and we'll see where it goes. So this is the cluster that we've pre-created in GCP, GKE. There are 4 Kubernetes clusters, one in each region. We have Asia, Australia, Europe, and the United States. And using those clusters, we are already running Vitess with these 2 key spaces. We have a user DB key space, which is sharded, and it has 4 shards. And we have an auxiliary key space called lookup, which is unsharded, which is what we will use to do the routing of the data. Let's take a look at what our schema looks like. So in the user DB key space, we have a single table called customer, and the customer table has an ID, a name, a national ID, and a country. So national ID is our sample column for representing data that's personally identifiable, and that is subject to the various data locality laws. And country is the field that we are going to use to decide how the data should be stored. This doesn't necessarily have to be country. It could be anything that pins the data to a particular location, either a geographic location or a legal jurisdiction. So that's what our schema looks like. And now let's look at the V schema. So we've defined a V schema for this key space. And first of all, it's a sharded key space, and it has a index called region VDX. And this index takes a map which tells the code which country belongs to which region. And it will use the ID and the country fields to compute a key space ID and store that in a mapping table. And we've then said that our customer table will be using this region VDX index, and the columns that it uses are ID and country. Now let's actually go try and insert this data and see what happens.
And could you please show everybody the insert customer SQL also?
Sure. Ooh. So while that's happening, let's take a look at what the data looks like that we are inserting.
So the point that I want to make is that these are simple insert statements with no regard to, there is no hint there about where the data should live. Your application hasn't changed at all. Your application does not need to concern itself with regions. It does not need to concern itself with where these cells are located, etc. These are simple insert statements that are inserting data.
And all we are inserting here into the table are the name and the national ID and the country. Now that we've inserted the data, let's go and look at what our Vitess control panel tells us. So earlier, we had 0 rows in this key space. Now that we've inserted the data, let's go and look at what that looks like. So we want to look at the UserDB key space. And in shard 40, which is located in East Asia, we have 4 rows now. And if we look at shard 40 to 80, which is located in Australia, we also have 4 rows of data. And we could do this for the remaining 2 shards, and we will see the same thing. But let's now take a look at this data in the database directly instead of going through a UI. So I'm going to connect to the key space or the database using VTGate, and this is giving me a unified view of the 4 different shards, 4 different physical databases that we have. So I'm just going to say, show me everything from the customer table. And what I get here is a scatter-gathered query. The query was routed to all 4 shards, and the results were gathered back together by VTGate and presented here. And this is a regular MySQL client that I'm using because VTGate implements the binary protocol. Now, let's look at the individual shards. So the syntax for that would be, I would say, use this database. And then select the data from this shard, -40, and there are 4 records. Now let's go to 40-80, which is our Australian shard, and sorry. And let's see what we have in that database. So shard 40 to 80, which is our Australian shard, only has data that belongs to Australia and New Zealand. It doesn't have data from any other countries which don't belong to the region. The other thing I want to show you is what is present in the mapping table. So how did we actually do the mapping of the data from a country to a region? So let's look at the mapping table, and the mapping table has 1 record for each row that we inserted into the main database, and it has an ID, country, and a key space ID, which is not very readable. So let's make that readable. So if we look at the hex value of that key space ID, we see that this is some computed value that doesn't really make any sense, but it doesn't matter. We don't need to know because the data is still getting routed to the correct place. Let's take a closer look at that hex value, and maybe it will make a little more sense. So now we can see that when the country is Australia, the hex value is always 40, and when the country is New Zealand, the hex value is always 41, and so on.
So this is the first byte of the hex value.
So this is actually, I extracted the first byte of the hex value, and for each country, we've defined a specific value that will then determine how the data gets routed. And that brings us to the end of the demo. Now we can take questions.
So one thing that I like, okay, we have a question here. We have, if you could come up here, we have,
so my question is, so you have this cluster with data that is distributed according to region. What if I issue an update statement that would change the region? And the second question would be, does Vitess support transactions? And like, how does that work in a situation where multiple shards are like used in the query?
should I take this?
I'll take the first one and you can take the next one. In general, you cannot change the columns based on which you have done the sharding, but recently we have built a new feature, a new framework in Vitess called vReplication, using which you can change the value of the sharding column, but you are effectively doing a resharding. So it is not a simple update, it's a more complex workflow, but you can relocate the data from one region to another.
Okay, thank you.
And the second question was?
About transactions.
Transactions, right. So what Vitess is really good at is co-locating data that needs to be together in the single shard. So for example, we had the customer table which is sharded using ID. Let's say that you have an orders table that has its own ID column, but it also probably has another column called customer ID, identifying the customer who is placing that order. So Vitess allows you to say, shard my orders table, not using its ID column, but using its customer ID column. So that way the orders associated with a given customer live in the same shard that the customer row is. What the effect that this has is that most of your queries and transactions all end up being single sharded. They are being sent finally to a MySQL database, and which is fully ACID compliant, right? As far as cross-shard transactions are concerned, so the typical example that I give is that you have a payment app and you're sharded using users, and one user gives other user money, credit from one row, debit into another row as a part of a single transaction. Those two users can either be in the same shard or it can be in two different shards. Let's take the example when they're in two different shards, right? So what we allow you to do is we allow you to use 2PC transactions. We have implemented two-phase protocol in Vitess where we do a prepare in shard 1, prepare in shard 2, commit in shard 1, commit in shard 2, and we write the redo logs in a sidecar database so that let's say that between commit in shard 1 and commit in shard 2, if shard 2 goes down and you need to fail over to another replica, the redo logs are in the sidecar database which have been replicated into the replica, and then after the new master comes up, we can decide either to roll back that transaction or to let it succeed. You have to keep in mind though that we don't provide isolation while cross-shard transaction is going on. So at the wrong millisecond, if you end up reading from two different shards, you might see an inconsistent view of the data.
Okay, thank you.
I think we are actually out of time, so
I think we have a few questions.
We are out of time.
That's fine.
Hopefully it's a quick one. Thanks for the presentation. What is the sharding function you used? Was it a custom function that you used for determining which shard each row would go into?
Okay. So the way we implemented the sharding function, it's a custom sharding function, and in the slides that are published on the website, there's a link to the source code.
Yeah.
So what that does is you can choose how many bytes of the key space ID you want to allocate to the region, and for each country, we've given a byte value, and the number of bytes that were chosen, in this case 1 byte for the region, we basically write this value into that byte of the key space ID. And the key range, the full key range from 0 to FF is divided into 4 equal parts. So this byte value then determines which fourth it belongs to. And the way we chose the values was such that Australia and New Zealand 64, 65 are exactly hex 80 and 81, so they go into shard 2. And China and Korea hex 1 and 2 exactly go into shard 1. So we chose the values for the country in that way.
Thank you very much. And these are our handles. Please ask questions if you have, or we will be available outside.